Okay, I'm unmuted. All right, great. Thank you so much, everyone. I'm excited to be able to join you virtually and look forward to talking to you. So I'd like to just go over the goal of the presentation, and that's to provide an overview of the programs and processes for supporting large-scale community-driven science. So I'm going to focus primarily on infrastructure because the processes and programs are a bit different than what many of you are familiar with. I will touch on the science, but Jen Wade did a great job of going into more detail on that on the first day of the meeting. So I won't spend as much time on that particular topic. All right. So I'm going to talk about the spectrum of infrastructure programs that are available at the National Science Foundation, going from small-ish to larger. And so the first is in the Division of Earth Sciences, we have an instrumentation and facilities program, and we have a newly revised solicitation. I encourage you to check it out. And there are multiple tracks in that solicitation for supporting a variety of different types of instrumentation and facilities. So these are things like supporting educational infrastructure, lab technician support, and lab operations. The amount of money that is available varies per track. So again, please look for that solicitation. Going upwards, we have the Major Research Instrumentation Program, or MRI program. So this program supports 2 tracks, but the program goals are to broaden access to multi-user instrumentation and for projects up to $4 million. So slightly larger projects can be supported by this program. Increasing in scale, we have the Mid-Scale Research Instrumentation 1 program, or MSRI program. And this supports both the design and construction or implementation of projects up to $20 million. And then we have the Mid-Scale Research Instrumentation 2 program, and that supports construction and acquisition of projects from $20 to $100 million. And then finally, we have the Major Research Instrumentation Facilities and Construction Program. MREFC is the acronym for this program. Many of you are familiar with this for the development of EarthScope, as shown here. It also supports the acquisition of, say, the ships in the Ocean Sciences program. And this supports infrastructure between $100 million and upward. I'm going to focus my presentation today primarily on these 3 mechanisms because people are less familiar with them, and the mid-scale programs are relatively new, so they started in 2019. And these programs are still evolving a bit as we work out the timeline and the scope of these programs. I do, however, just want to make sure you consider the IF and the MRI programs as you consider what is appropriate for building out your vision for SZ4D. Before I go into the specifics about these infrastructure programs, I want to take a step back to discuss how we frame the life cycle of infrastructure at the National Science Foundation, because we consider and fund each phase of these life cycles separately and distinctly from one another. We don't do this on the science side, so I want to fill you in a little more about each one of these phases. So first is the development phase. So this is the stage where ideas emerge, broad consensus is built, the long-term needs, priorities, science requirements are developed. I would say that the SZ4D community is in this development phase. The design phase is next. And so this is where detailed, construction-ready requirements for scope, schedule, budget, risk analysis is done. So at the end of the design phase, projects should have very well-defined plans for then that would be used in the next phase, which would be the construction phase. So in the construction phase, this is when funds are obligated to construct, acquire, develop that physical infrastructure. Next would be the operations phase. Once the facility is constructed, then it moves into an operations phase, and this is the day-to-day activities that are needed to operate and maintain the infrastructure. Many of you are familiar with the SAGE and GAGE seismic and geodetic facilities. They are in the operations phase. And then finally is the divestment or closeout phase of the project. Divestment can take many forms. We can transition infrastructure to different operators, or we can completely dismantle and remove infrastructure from the ground. So divestment takes many phases, or there's many different types of divestments. A couple of additional comments on this life cycle plan. So as I said, NSF views these different parts of the life cycle distinctly and different from one another. Programs tend to fund things within these individual boxes, not across the boxes. Please also note that we fund the development, design, operations, and divestment parts of this out of core division funds. There tend not to be special foundation-wide programs for those parts of the infrastructure lifecycle. So please consider this when you talk to NSF program officers or when you're considering what your plans are. There's many competing priorities across different divisions for different subdisciplines across our portfolios. And so please consider that we do have to support these elements out of core program funds. Also, the whole life cycle of the infrastructure, so this includes what the operations and divestment plans are, they need to be determined in that design phase. This wasn't always the case at NSF. For past MREFC projects, we may have kicked the can down the down the street here and determined the divestment phase much later, but we don't do that anymore. The divestment phase has to be determined during that design plan timeline. Additionally, the length of time for operations and divestment have to be tied to the science. The choices for the length of time for operations and what happens during that divestment phase really need to be focused on the science questions and how best to address the science that's proposed. So again, this is very different than what we do on the science side. So I wanted to take the time to kind of dig into this, and we're going to use this framework for the rest of the talk. A couple of other considerations. There are many approaches to building large initiatives. They can be built out of smaller building blocks, or they could be one single large scale project. But there's value to approaching these in different ways. So I encourage you to be realistic and be flexible about how to achieve the science goals that you have. Also, please note for the mid-scale projects and larger, these are going to be reviewed by many stakeholders. So some will be science experts in our field, but many will be project management experts or scientists from other disciplines. So there will be biologists, astronomers, chemists reviewing these proposals. So whatever you propose has to be compelling and has to make sense to non-experts and experts alike. Also, I want to clarify that NSF does not support monitoring of man-made and natural hazards. While some of our infrastructure is dual use and is supported for this, there has to be a compelling scientific goal that is articulated for justifying the development of that infrastructure. So if I've heard a lot of talking about wanting to monitor things, and we don't monitor with our facilities, but we build our facilities for specific scientific goals. And then once those goals are met, they're divested. So digging into the mid-scale research infrastructure 1 program. So if you look down at the bottom, we have the life cycle phases that I talked about. And this program supports projects in the design and construction phases. So I get a lot of questions. Should I submit a design proposal or should I submit an implementation proposal? So a design proposal should be thought of this way. The end state of a design project is a fully developed construction-ready design. So if you're not really sure exactly what you want your infrastructure or facility to be, it's probably appropriate for a design phase proposal. And those can be between $400K and $20 million. There are other processes for building and for designing projects, but the Mid-Scale 1 program specifically has a track for this. For implementation projects, the end state would be a fully acquired or constructed facility that's ready to enter an operations phase. So if your proposal and your vision is to, at the end of the project, be ready to start operating and collecting data for science, that implementation track is the right one for you. For these mid-scale programs, there's a requirement that you build a project execution plan and a well-developed one. I'm going to talk a little bit later about this and how to do that. But I want to talk about the Mid-Scale Research Infrastructure 2 program. So this supports projects between $20 and $100 million. As we scale upwards, right, the number of stakeholders that are engaged in these projects grows, and important, it's really important that you're involving those stakeholders in the development process. You really, in order to be competitive for this program, whatever the concept is, should be well articulated in community documents such as National Academies reports. So the facilities that would be supported by this program have to be multi-user, there has to be a broad user base, and it has to address fundamental science questions that otherwise could not be addressed by the program. These are reviewed by the National Science Board. So they're similar to the MREFC projects where they get a significant amount of scrutiny. They also go through an independent project execution plan review. So the scope, schedule, budget, risk analysis, project management methodology is significantly scrutinized and has to be extremely well developed. If it fails that review, it gets kicked out of the program. So the science and technical parts of the project are important, but the execution plan for achieving those goals has to be watertight. And so a couple of additional pieces of information for developing these proposals. If you're considering these programs, we strongly recommend that you look up the NSF Research Infrastructure Guide, or RIG. There is a chapter that's fully devoted to providing guidance to the community on developing mid-scale projects. And there's lots of information on developing that project execution plan. So there's a template that's available and additional information about the level of detail that's required for the different programs. I strongly encourage you to review the RIG, as well as consider attending NSF's research infrastructure workshops. So the most recent one was in September. We anticipate another one in fall of 23, but there are specific sessions devoted just to mid-scale research that are very useful in helping you to build out your vision for these proposals. I want to take a minute to talk about some of the iterative project concepts that I've been hearing at this workshop. So I realize there have been conversations about saying needing to determine where the lock zone of a subduction zone is before building out the full scope of a project. That's just one example. And it's really critical that you consider the program boundary conditions when you're planning out your project phases and making sure that the programs that you're submitting to, that you're aware of what their boundary conditions are and which ones fund design and which ones fund construction or implementation of your projects. The project execution plans for the mid-scale 1 and 2 programs, especially for mid-scale 2, so that's the scope, schedule, budget, where you're going to put instruments, your planning for permitting and land use agreements. All of that needs to be very well developed at the time that you submit the proposal. So just be aware that doing these iterative projects would require aggregating or combining multiple proposals in order to really achieve your goals. And so we're happy to talk to you more about that after the meeting. Then finally, the Major Research Equipment and Facilities Construction, or MREFC program. We get a lot of questions about this. So here what you see is the same life cycle plan schematic that I've been showing you, but in a little bit more detail. So the MREFC program supports projects larger than $100 million. So that's like EarthScope, the ships, the ocean observing facility. But there's a few things to note about the individual parts of the life cycle. So the development process is probably the most difficult process after divestment, and it can be very lengthy. In order to enter the formal MREFC design phase, so going from the development phase to the design phase, there has to be significant consensus building across the NSF. So you have to have buy-in across the divisions, the directorate, and through the director's office to go from this development phase to the design phase. In between each one of these phases, there's phase gates, and there are multiple phase gates that include a lot of external review by technical experts and project management experts, as well as once you enter the design phase, there are multiple phase gates even within this. I encourage you to look this up in the RIG because the National Science Board will review many different components during that design phase. There has to be a lot of community and NSF interaction during this development and design, these development and design phases. So there's a lot of interaction between the research community and NSF to come up with the final design. But once the design is finalized, NSF takes that design and it issues a solicitation where that's openly competed. Any entity that wants to submit a construction proposal can submit a proposal to NSF to then construct that facility. So this is where NSF takes a bit of a hands-off approach to interacting with the community so that we can fairly and openly compete the construction of that facility. The facility is then constructed, and then once the construction phase is over, NSF issues another solicitation for the operations phase. So you can have multiple entities, different entities do the construction and operations of a facility. Again, during that operations phase, there's periodic recompetition for the operations of a facility. And then finally, the project is divested at the appropriate point in time. So these infrastructure programs work hand in hand with our science opportunities. So I know Jen Wade said this, but please consider ways that the core programs can help support your vision. We do share across programs, as Jen said. I will second Jen's comment about proposals that are reviewed by multiple programs tend to fare better than proposals that are only reviewed by individual programs. So please take that into consideration. We also have the frontier research in the earth sciences for projects that are just a bit too large for those core programs. We have centers programs like the Centers for Innovation and Community Engagement and Geohazards, but there are other centers programs across the foundation that can help coordinate large-scale science goals. And then finally, I do want to just mention that, I know the EarthScope program had an independent science program. GeoPrisms was an independent science program, but those were developed at a very different time in NSF's history. And independent science programs that would go on to fund specific infrastructure or science using specific infrastructure, that really does come from the core division budget. We really do have to balance our portfolios in our divisions across many subdisciplines. So I just want to manage your expectations about realistically where the science funds are going to come from to support science for these initiatives. So moving forward, I can't emphasize this enough. Science questions should really lead where you're going. Be mindful of the program boundary conditions and consider the different parts of the life cycle and where your projects fit into the life cycle of facilities and infrastructure. Again, you can build a community initiative out of smaller components that will meet your science goals. There's many different ways to meet your goals, whether it's building components out of smaller projects or whether you have one very large project. But if you do want to be competitive for those larger programs, you have to have a very clear, coherent, and integrated whole with extremely strong project management. So I'm going to leave you with contact information for the program officers for these individual programs. And I know there's not too much time for questions, but I'm happy to answer them now, or people can contact me later.